Good morning, this is Mr. Precella. I'm continuing to work with my face-to-face Math 1324 class on the review sheet for the final exam, and we're ready to do number 22, which is a linear programming problem. It's a graphical method. It says find the maximum and minimum of p equals 11x plus 5y subject to these constraints. X is bounded between 0 and 10, y between 0 and 5, and 3x plus 2y is greater than or equal to 6. Well, in order to graph this feasible region, these first two constraints, x between 0 and 10, y between 0 and 5, is going to form a rectangle. In order to graph 3x plus 2y greater than or equal to 6, we'll think of it with an equal sign and graph the boundary line. And I'll do that just by finding the intercepts. Plug a 0 in for x, solve for y, we'd have 2y equals 6, so divide by 2 to get y equals 3. There's 1 point. Then plug a 0 in for y. So you'd have 3x equals 6. Divide by 3 to get x equals 2. You can probably do that in your head. 3 times what is 6? 2 times what is 6? Now, to graph this, let me set up my rectangular coordinate system using some of this graph paper provided by Pearson. Okay, so x is between 0 and 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That would be x between 0 and 10. And y between 0 and 5. 1, 2, 3, 4, 5. Now, you'll see why I'm saying it's a rectangle. We want the x values that are between 0 and 10, and all the y values between 0 and 5. So if this were the only feasible region, then the feasible region would just be the shaded rectangle right here. But we have this other constraint, so let me draw that. Over 0 up 3, 1, 2, 3, that's 0, 3. Right 2 up 0. Draw that line. And now we're going to shade either above that line or below. Usually if there's a greater than, you're shading above, but we'll go ahead and test a point. Choose any ordered pair that's not on the line. I'll use 0, 0 and plug it in. And we're 3 times 0 is 0. 2 times 0 is 0. 0 plus 0 greater than or equal to 6. That is false. So we don't want to shade on this side of the line. So our feasible region is going to be right here. So can we write off those ordered pairs? I mean the corner points. There's 5 of them. Well, this one right here is 2, 0 corner points. There's 2, 0. Oops. And this one right here is 0, 3. Now this point right here, where it's passing through 5 on the y-axis, how would I write that as an ordered pair? Well, that'd be 0, 5. That point right there, it's at 10, 5. And then right here, oh, nothing wrong with your computer. The lights And since I'm not up moving around and everyone's so still, the lights sometimes go off. Right 10 up, no, this one right here, over 0, up 10. We'll plug each of those into 11x plus 5y. And the smallest number we get will be the maximum, the largest the minimum. Notice this is a closed and bounded region, so there's definitely a maximum and a minimum at one of these corner points. Plug us 2 in for x and a 5 for y, that would get us 10. A 0 and a 3 would get 15. 0, 5 is 25. What about this 10, 5? 11 times 10 is 110. 5 times 5 is 25, so that's going to be a 135. Over 0 up 10. Excuse me, plugging a 0 in for x and 5 for y. Is that going to be just a 50? So the biggest number is our maximum. So the maximum is 135, which occurs at the ordered pair 10, 5. And our minimum is 10, which occurs at the ordered pair 2, 0. I don't think it's asking where do they occur. It's just what's the maximum and what's the minimum. So we're looking for 135 and this is interesting here. Sometimes on the let's see, unless I missed. Oh wow. 2, 0, that's not it. 11 times 2, that's a 22. So the minimum is 15. It's a good thing it's a multiple choice. I was able to spot that 2, 0. If you plug a 2 in for x and a 0 for y, I think I put a 0 and a 2, didn't I? So that should have been a 22, which means the minimum should be 15 and the maximum 135. Okay, so a B there. Now, we're going to do a word problem. Let's see. Starting with number 23. I need to zoom in that more so y'all can see it better. Acme Ring Company designs and sells 2 types of rings, the VIP and the SST. The company can produce up to 84 rings each day using up to 210 total man hours. Takes 3 man hours to make 1 VIP and 7 man hours to make 1 SST. Let X be the number of VIP rings. It's number 23. X is the number of VIP rings and Y is the number of SST rings. Find the system of inequalities. Okay, so we're just finding inequalities. Right off we're told they can produce up to 84 rings. That sounds sort of like a total here. When it says up to 84, that means 84 or less. So there is one inequality. X plus Y is less than or equal to 84. Then we're told that they can use up to 210 man hours. It takes 3 man hours to make a VIP, 7 to make an SST. They can use up to 210. That up to would be another inequality. Another less than or equal to. And hopefully at this stage of the game you've gotten pretty good at setting these up. It'd be a 3 hours for every VIP plus 7 hours for every SST less than or equal to 210. And let's throw in the obvious non-negativity constraints. You can't have a negative number of rings. So X and Y are both non-negative, greater than or equal to 0. Let's see, which one is it? Is it B? Yeah, this one's B also. Okay. Just sort of working through these. Now, let's do number 24. It's another word problem. And I may have room to do it right here. So we're doing number 24. The Penny Company manufactures ballpoint pens, silver and gray. No, silver and gold. The silver requires 9 minutes in a grinder, 7 minutes in a bonder. The gold requires 11 minutes in a grinder, 5 minutes in a bonder. The grinder can be run no more than 370 minutes per day. The bonder no more than 200 minutes per day. Let X represent the number of silver pens and let Y represent the number of gold pens. So this is number 24. So X is the number of silver pens. Y is the number of gold pens. There's going to be a grinder and a bonder. The silver requires 9 minutes in the grinder, 7 minutes in the bonder. The gold requires 11 minutes in a grinder, 5 minutes in the bonder. The grinder can run no more than 370 minutes. No more than, that would be less than or equal. The bonder, no more than 200 minutes. That would be less than or equal. So we're going to find the system of inequalities. Well, there's the grinder constraint. 9x plus 11y is less than or equal to 370. 9 times the number of silver pens. It's taking 9 minutes for every silver pen, 11 minutes for every gold pen. Then over here, 7 minutes for every silver pen and 5 minutes for every gold. And then we have the non-negativity constraints. X and Y can't be 0. When we're using PHP Simplex and getting answers to these, when we're actually got a problem where we're maximizing or minimizing, PHP Simplex always assumes there's non-negativity, but they're still there. Let's see. 9x, no. 9, 11, 370, 7x. Is this another B? Yeah, it's not those. Okay, we're on a streak. Let's see, what's the next one? Oh, the old rainforest problem. Let's see. A certain area of the rainforest is populated by 2 different species of animals. Which scientists refer to as A and B for simplicity. The forest supplies 2 kinds of food, referred to as F1 and F2. For 1 year, an animal of species A requires 1.3 units of F1 and 0.9 units of F2. For 1 year, an animal of species B requires 2.1 F1, 1.9 unit F2. The forest can normally supply at most 847 units of F1 and 462 units of F2 per year. So, number 25. Let lowercase a represent the number of animals of species A, and let lowercase b represent the number of animals of species B. Let's see. We have 2 columns here, F1 and F2. For 1 year, an animal of species A requires 1.3 units of F1 and 0.95 of F2. B, it's 2.1 F1, 1.9 F2. So species B eats more, that's for sure. And then we're told that the force can normally supply at most, that's another less than or equal to. So we have the F1 constraint and the F2 constraint. How would we write it out? Well, 1.3A plus 2.1B is less than or equal to 847, and 0.95A plus 1.9B less than or equal to 462. Can we have a negative number of animals? No. So A and B must be greater than or equal to 0. Let's see, which one is it? Looks like A, is it? Oh, I was about to say, what's the difference between A and D? D, reverse those. C, put a greater than rather than a less than. It is A. Here's another one. For 26, a breed of cattle needs at least 10 protein and 8 fat units per day. Feed type 1 provides 5 protein, 3 fat units, and costs $4 a bag. Feed type 2 has less protein, more fat, 3 protein, 4 fat units, and costs less. Well, that makes sense. Which mixture fills the needs at minimum cost? So this is one like we did where you actually have to write it all out. It doesn't tell you what the variables are. You're going to have to write it out. So what would we, how would we set this up? Well, it's going to be a minimized problem, and you see they're using the variables x and y. So let's identify what these x and y are. Which mixture fills the need at minimum cost? So what we want to know is how much feed type 1 and how much feed type 2. So feed type 1 and feed type 2. The amount of or number of bags. Let's see, we have the protein and the fat and the cost. They need at least 10. That's one of those totals. Protein units and at least 8 fat units. Now what does, well, let me go ahead and feed type 1 provides 5 protein, 3 fat, costs $4 a bag. Feed type 2 provides 3 protein, 4 fat, costs $2 a bag. Now we're told that they need the breeder cattle needs at least 10 protein. Now at least, would that be less than or equal to or greater than or equal to? Well, that would be greater than or equal. This wouldn't make sense to say they're going to feed the cows, less than 10 grams of protein or 10 units of protein. What's going to be cheapest? Well, if they were trying to feed them less than 10, just don't feed them anything. Let the cows go without eating. That would be the cheapest thing to do. But no, they've got to feed the cows at least 10 units of protein and at least 8 units of fat. They want muscle and they need some fat for the flavor. So this is minimize the cost, 4x plus 2y. Subject to, we have the fat constraint, 5x plus 3y greater than or equal to 10. And, we lift that up. And 3x plus 4y greater than or equal to 8. And of course we have the non-negativity. And this is what you would punch in, say, into PHP Simplex in order to get an answer. So there we've set it up. which one is it? Is it B? 4x plus 2y, 3? Yeah, it is B, it looks like. Number 27, how to find the pivot. Now this is something Jesus kept having trouble with. To find the pivot, you choose the most negative number in the bottom row, that gives you the pivot column. So the most negative number down here would be -8. So here's the pivot column. And now divide the last number divided by the corresponding entry in the pivot column. 10 divided by 6, that would be what? 1 and 1.666. 20 divided by 2 is 10. 40 divided by 4 is also 10. Of these numbers over here, you choose the smallest positive quotient. Quotient is the answer to a division problem. And so this would be the pivot row. The intersection is the pivot. So the pivot is the number 6 in row 1, column 3. 6 in row 1, column 3. So most negative number on the bottom row, divide smallest positive quotient. The last one deals with bakery. Let me tear this off so you can see it. I'm sort of oops. There. A bakery makes sweet rolls and donuts. A batch of sweet rolls requires 3 pounds of flour, a dozen eggs, 2 pounds of sugar. A batch of donuts, 5 pounds of flour, 3 dozen eggs, 2 pounds of sugar. Set up the matrix to maximize profit. So if they're going to maximize profit, well, what we want to know ultimately is how many sweet rolls and how many donuts should they be making. Okay? You're not trying to figure out how much flour, eggs, and sugar they're making. You're trying to figure out how many sweet rolls and how many donuts. So looking at how it's set up, I'll use x1 for the number of batches of sweet rolls and x2 number of donuts. A batch of sweet rolls, looks like we have what column headers? Flour, eggs, sugar. A batch of sweet rolls requires 3 pounds of flour, 1 dozen eggs, 2 pounds of sugar. A batch of donuts, 5, 3, 2. Now, then we're getting some totals here. They have 380 pounds of flour, 290 dozen eggs, 270 pounds of sugar, and we're going to assume they don't want to go buy more. That's how much they have, so they can't use more than this amount of flour, eggs, and sugar. So that would be less than or equal to. Then we're also told something about the profit on a batch of sweet rolls is $11. And on a batch of donuts is $8. So to set this up is a maximize. We want to maximize the profit. 11x plus 8y. Subject to, we have those three constraints. 3x1 plus 5x2 less than or equal to 380. 1x1 plus 3x2 less than or equal to 290. 2x1 plus 2x2 less than or equal to 270. To set up the Simplex method, you start off by introducing slack variables wherever there's an inequality, a less than or equal to. And so there's going to be three slack variables. And if we look at this, just look at how they're setting it up. They're not using s's for slack variable. They're just continuing on with the next x. x3, x4, x5. Oops, and I said x and y, but it should have been x1 and x2. There. So, to set this up, oh, notice they have x1, 2, 3, 4, 5, and an x6. So the z, they're calling x6. Okay, so x1, x2, x3, x4, x5, x6 equals, now I'm moving this up, I'll write this first row. It'd be 3x1, 5x2, and x3, zeros, 380. The second row right there, 1x1, 3x2, no x3, x4, 290. And I'm doing that third row, I'll do that in green. 2, 2, 0, 0, 1, 0, 2, 70. Now, the objective function, this one here, oh, that looks so messy. Let me write x6 equals 11x1 plus 8x2. Well, you've got to move all of this stuff over. All the variables are on the left with just a constant on the right. So that would make this a negative 11, a negative x1, 3 zeros, a 1, and a 0. Maybe I can figure out which one the answer is without actually writing out. A lot of times I can see it just based on this last row. There's only one that has the negative 11 and the negative 8. If you look closely at that one, and the matrix I have, I'm thinking it is D. Okay. So D, setting it up. Okay. And that's the last one. So that does it for today. Ooh, the lights have dimmed. So I will, well, good luck studying for your final. And thank you for listening and watching. Bye-bye.